Hi, and welcome to today's video. I've chosen 4 books all about science that we can read together. Our first book is going to be Newtonian Physics. And then we're going to get to read all about rocket science. And after rocket science, we're going to go ahead and read about general relativity. And our last book is going to be quantum physics. So are you ready to go ahead and start reading with Newtonian physics? Great! Now these books will give us some simple explanations on some complex ideas. And Newtonian physics is where we'll start. Newtonian physics for babies. This is a ball. See the ball? The ball feels the force of gravity. The force of gravity is the green arrow. We can't see gravity. It is the force that keeps us on the ground. The force of gravity pulls the ball down. See the green arrow? The force of gravity pulling the ball down. This ball is on the ground. It still feels the force of gravity. See the ball on the ground? And it's still feeling the force of gravity. But it also feels the force of the ground. See the red arrow? That's the force of the ground. The force of the ground equals the force of gravity. See how the force of the ground, the red arrow, is the same size and equals the force of gravity, the green arrow. The net force on the ball is 0. It does not change its motion. See how the ball is just sitting there? It's not moving. This is a ball. This ball has a net force. See how the ball is in the air? And look, the green arrow, it has a net force of gravity. It does change its motion. It accelerates. See how it accelerates with the force of gravity towards the ground? This ball has mass. See the ball? It has mass. This ball has more mass. See the bigger ball? More mass. This ball has less mass. And here's our smaller ball. It has less mass. More mass, more force. Less mass, less force. See how the ball with more mass has a bigger force arrow? And the smaller ball with less mass has a smaller force arrow. The force of the ground always equals the force of gravity. See the two balls? They have different mass, but the force of gravity and the force of the ground for each ball is the same. This is Sir Isaac Newton. He wrote 3 laws of motion. When this apple falls from the tree, it does not float away. This apple feels the force of gravity. See the apple with the green force of gravity arrow? Sir Isaac Newton feels the force of the apple. Now you know Newtonian physics. Newton's first law of motion: if an object has zero net force, it does not change its motion. Newton's second law of motion: the net force is equal to mass times acceleration. And Newton's third law of motion: for every force, there is an equal force in the opposite direction. What a great book! Now on to the next. Rocket science for babies. This is a ball. See the ball here? This ball is moving. See the yellow arrow to show the ball is moving? Air can't go through it. Air goes around it. See all the air, the gray arrows? And see how the air has to go around the ball? Change the shape of the ball to change the airflow. Do you see how the airflow now looks different than on the ball? Change the angle of the ball to deflect the air down. Now look at the airflow. See how it's going down? If the air goes down, the shape goes up. See how the air is going down? And that is pushing the shape up. The upward force is called lift. This is the shape of an airplane wing. This ball has no lift. The wing has lift. But how do we make the wing move forward? We put it on a rocket ship. This ship is full of fuel. See all the fuel in the rocket ship? If the fuel goes out, see the fuel showing that it's going out? What do you think happens? The ship goes forward. See the fuel going out and the ship going forward? The faster the fuel goes, the faster the ship goes. So we make it explode. The forward force is called thrust. With lift and thrust, we can go to the moon. Now you are a rocket scientist. That was a great book. Now it's time for the next one. Our next book is General Relativity for babies. This is a ball. This ball has mass. More mass, less mass. This is a flat space. Mass warps space. Less mass, less warp. See how the more mass in the ball makes all the lines warp more? And less mass, less warp. More mass, more warp. This is a small particle. See the small particle right here? It wants to go here. See how this small particle wants to go here? But it can't. It must follow the shortest path through curved space. This ball is spinning. Mass drags space. Space drags mass. See how the spinning ball drags the space? And see how the space drags mass? This is a flat space from a different angle. See mass warp space from this angle. See the ball with mass? See how it warped the lines on this space? Shrink a large mass enough and it becomes a black hole. See the large mass shrinking into a black hole. A black hole is a large amount of mass in a relatively small area. See that small black hole? It has a large amount of mass. A black hole has so much mass that not even light can escape its warp. The center of a black hole is called a singularity. See how the black hole has warped the space? Two black holes can spin around each other. See the two black holes and they're spinning around. When they do that, they send ripples through space called gravitational waves. See the red gravitational waves from the black holes spinning around each other? These waves stretch and squish space throughout the universe. Now you know general relativity. What a great book! Let's read the next one. It's time for the last book in this video, Quantum Physics for Babies. This is a ball. See the ball? This ball has energy. Look at all the energy around the ball. This is a ball. This ball has zero energy. See the ball? There's no energy. All balls are made of atoms. There are neutrons. See the purple neutrons? And protons. See the red protons next to the neutrons? And electrons. And look, there are the green electrons. An electron can be here or here or here. But an electron cannot be here. See how the electron cannot be here. Or here. The electron cannot be here. all electrons have energy. See all the energy around the electrons? This electron has the most energy. Look, the electron furthest away from the neutrons and protons has the most energy. This electron has the least energy. And look, here's the green electron closest to the neutrons and protons, and it has the least energy. There are no electrons with zero energy. This energy is quantized. An electron can take energy to jump up. See how the electron here on the ring took in the energy and it jumped up. And it must give energy to fall down. See our electron? And it's giving energy, and that means it falls down. This amount of energy is a quantum. Now you are a quantum physicist. What a great book! Wow, those were some really great books. Don't you think so? Yes? Great. Well, if you enjoyed today's video and reading along with me, please don't forget to like the video. Thank you so much, and I'll see you next time where we get to read together again. Thank you for watching. Please don't forget to subscribe, like, because more readings are coming soon.